evaluate the double integral of x squared z ds, where s is the portion of the cone, z squared equals x squared plus y squared, that lies between the plane z equals 1 and z equals 4. And you can just see this in the picture below. It kind of gives you everything you need here. So hopefully your thoughts for the parameterization for this problem is cylindrical coordinates, because this is more of a cylinder kind of problem. And an indicator for me here is this x squared plus y squared. I automatically think of that x squared plus y squared equals r squared. So right away my mind goes to cylindrical form here. For any cones, paraboloids, because I'm going to get that x squared plus y squared or a variation of that, so that's going to give me that r squared. So that's my first thoughts anytime I see any of those equations. So we're going to go with cylindrical here. So here are the cylindrical transformation here. So we're going to look at then is we're going to look at our x, and we're going to use u and v. So we're going to go with our ru v here. And we're going to go with x equaling r cos theta. So that means I can say my u equals theta and my v equals r. And it doesn't really matter which variable you use. Just be consistent with it when you plug it in. So then for my RUV, I'm going to get v cos u, comma, v sine u. And again, hopefully you can see how that's coming into play. So my x is going to be the first one. And then my y is going to be the second one here. And again, all in terms of u and v, of course, as well. And then our z is kind of the strange one we got to work out by its equation here. So the equation for this one is z squared equals x squared plus y squared. Now that tells me, I'm just going to write it out. So that tells me z squared equals r squared. And remember, my v equals r. So that means it equals v squared, since my v equals r. So really what I'm saying here is z squared equals v squared. So then z equals v. So my z is actually v here, so I can just put a v there, and there is my RUV. So now I'm going to need my RU. So then my RU is going to be negative v sine u, comma, v cosine u, comma, 0. And that's my RU. And then my RV is going to equal cosine u, comma, sine u, comma, 1. And then we're going to do the cross product of those two. So there's my cross product. Now I'm going to take the magnitude of that. And before I write it all out, I just want to let you know that, hey, I can pull a v out of those two, and that's going to actually just be negative v. So I'm going to square that too when I do the magnitude. So there it is, and I can see right here as well that I can pull a v squared out of those two, and that's just going to be a v squared plus v squared. So this is actually going to be square root of 2v squared, which is square root of 2v. So I'll get these coordinates out of here. We don't need those anymore. And I'm just going to move this over. I'll move that over here. And I can just move these up, because I'm going to need some more room here to do my actual integral. So we'll move it up there. Now we can actually do the integral here. And remember the formula for the integral. And remember here, my x is actually v cos u. So it's the double integral. I'm not going to worry about bounds right now. We'll get to those in a minute. So that's going to be x squared. So that's going to be v squared cos squared u. And then times z. And my z is v times v. And then I'm going to have a du dv. And remember, my u equals theta. So I'm going to do that one first then, it looks like. Yep, so that's going to go from 0 to 2 pi because I'm going to go all the way around here. And then I'm going to talk about my v here. Now my v equals r, which my v also equals z here. So that tells me then that since my z goes from 1 to 4, then my v would go from 1 to 4. And now this is my integral here that we're going to actually plug in. Oh, I forgot one component here. Ooh, I almost forgot about my TU cross TV. We did all that work for it. We didn't even use it. That's going to be this square root of 2v. All right, remember this v is this z here that we see. All right, now we're ready to roll. So I will clean it up a little. Oops, 1 to 4. 0 to 2 pi. And then this is really square root of 2, v to the 4th, cosine squared u, du, dv. And I'm just going to use my calculator for this answer here. But again, you may have to do something like this by hand. This isn't a hard one to do by hand. I will have to use one identity here for this cosine squared u. So this is going to equal 1023. Let me fix my 1. Square root of 2 pi all over 5. So there's our answer for this problem here. Very nice problem. Hopefully the RUVs are getting better for you guys. And again, those are just direct subs. I can plug those in and just do my cross products, magnitude. And that's what I actually plug in for my DA. That's my component for it. So that's our answer for this one.